Hi. All right. Yeah. So this is not exactly a live stream. I'm uploading this one kind of ad hoc because what happened was that even though I promised that I would only like hack away at this code while live streaming, I was on the train and I had some time and internet connectivity was cutting in and out. So I played around with this and it turns out that I was actually able to resolve some issues and spoiler alert, got stuff rendering. So we're in good shape. What I wanted to do is, even though I didn't live stream it, I want to like kind of quickly go over the fixes so that there is a continuation. And then the next stream, which I think will be on Sunday, will be a longer proper live stream session. So this will just be a quick like kind of glue between the last live stream and the next one, and explaining just a little bit of what I resolved on the train and got some help from the community and learned a little bit about. So this won't be a long one, which is why I'm not live streaming right now. So anyway, there were really just two major issues. One was the whole request animation frame loop, which I asked for some more documentation from the Rust team, and Alex was kind enough to add great comments. So I'd suggest just looking at the request to animation frame official example, and it has like all the comments explaining what's going on. On a basic level, the issue is that this closure needs to be a static lifetime. I think that's one of the big issues, and therefore anything that it references needs to be an owned value or static. So what I was passing before was a reference to the GL, which was outside, and I couldn't make it static because it's like it's created at runtime, and actually I don't know. I need to learn more about that. Like, can you create something and still have like a static lifetime for the rest of the program, like till the end? I don't know. But bottom line is that by passing it in as an owned value and moving it in, that fixed it. That was the only thing I need to do. That was the big bug with the request animation frame loop. Now, the actual understanding of how this whole works, how the loop works, the truth is if you kind of step through it carefully, it makes sense, but better to look at the comments and see how they explained it. Like on one foot, though, we could see like F is a G is a clone of F, so we're like kind of calling in a sense G here and reassigning it to G. This was a tricky thing of this like auto dereference for seasoned Rust developers. They would probably see that right away, but I was confused by it. But it's pretty straightforward that like by dereferencing G, which is basically F, because RC implements deref and refcell implements deref. So what we're really getting at here is the dereferenced inner value, like we're going in the RC and then going in the ref cell, and then like that's the inner value that we're getting. So it just like follows that deref chain. So we're just assigning like a new new option like here, right? That's what we're assigning here. And then closure wrap has to accept a box. I don't really know why. I'd like to learn more about that. But bottom line is that that's what it has to accept is a box of an inner closure. So that's what we give it. And so yeah, so that works. So that's the request animation frame. Again, the fix was just passing GL as an owned value. The other issue that was stopping rendering from working was this. What we had before, actually this comment wasn't here either, but what we had before was this, right? And if we compile that, we'll see that'll break our rendering. So now we're not getting anything on the screen. The reason, also looking back, is really straightforward. If we log the values, like what we want here, let's just do this. Like if we actually here, let's just console log 1. If we log this thing that we're passing, this float32.buffer, so we'll float32.buffer, okay. Hey, okay, yeah. And what we want is format should have this number of values, and what we really want is values.lin, right? Like the number of values in like the data that we're uploading to the GPU should be what we're passing in. These like, you know, the number of values in this vector of float 32s that we're passing. So if we run this, we'll see the bug right away, is that we should have 8 values, but we have a hell of a lot more, right? It's a big number. And that is ultimately the issue. And the reason is that this is really just a JavaScript thing, is that a typed number array, or typed array, a typed array, like a float 32 array, it's a view, like it's a view on an array buffer. And the view has a start and an end. So if you just pass the backing array buffer, it could be a one-to-one. Like you could have a float 32 array that is backed, of 8 values. It's backed by an array buffer of 8 values. But in this case, because we're creating the view on our WebAssembly memory, like we have just a big giant buffer of the WebAssembly memory, and what we're passing in is a pointer, or actually like a view on that memory with a start and an end, like a specific section. So that's just the bug here, is that by passing the array buffer, we're passing the entire memory, and like that's not going to work. So what we need to do is instead, before we do it, let's actually, like while we do it, if we pass in just like the float 32 itself, which is an array buffer view, right? A typed array, it's the same thing. A typed array is an array buffer view. I guess you also have a data view, which is another type of array buffer view. But anyway, that's, they're pretty synonymous. So if we run this, first of all, we'll get our rendering, and then we'll see, should have 8 values, and yes, we get our float 32 array with 8 values. So that was it. We were just passing the whole memory, and like we had to pass a view on it. And yeah, that's the fix. I'm leaving this comment in, even though it's like not relevant for what we're doing right now, just as a hint that like it would be nice, like if we're gonna have like try and use WebGL 2 and then use a WebGL 1 fallback, which I do eventually want to plan for, we want to change this method. But there's more stuff going on that I think I'll pick up on Sunday, and like continue the live coding, live streaming. Like I'm not sure if we really want to accept a vector here. Like I don't think that's really right. And we want to move this stuff out to the library. Right now it's in the example code. And then we'll do a lot more from there, and maybe start loading textures and get, sprites going and stuff like that. So until Sunday or next time, have a good one.